We are live right now. So, hello, audience. And here today we have Klaus with us. I think I have pronounced it right.
Hmm.
So, Klaus is a specialist in semiconductor market research and dynamics. He has his specialization on this area. I don't have much knowledge about that, so I cannot go ahead with a lot of info on that. So, today we will be talking about couple of matters together. So, Klaus, my first question is that can you tell us about a bit your background and how you become interested in the semiconductor market research?
Sure. So many moons ago, when I was a young engineer, I got lured into semiconductors, and quite fast after that, I got lured into, can you say, the commercial aspects of the semiconductor business. Well, shortly, I grew the ranks and were a director and group level manager with responsibility over large areas of different parts of the world. And suddenly, your focus moves from what is actually going on in the market to resource allocation. Um, but at, can you say, a point in time in my career, I was listening to my CEO, and he was saying, this has been a very good quarter. We gained market share and blah, blah, blah. And I said, okay, that sounds fine. Let me go and check on our competitors. And so I took our key competitors and checked out what their CEOs said. And they said exactly the same. It's great. And we all gained market share. And then said, okay, I expanded a little bit. So I think I took 40 companies in the semiconductor industry, and they all had a great quarter and all took market share. And I was like, okay, like Mark Knopfler says, if two men say they're Jesus, one of them got to be wrong. Okay, so that's my first attempt. And what I did was I just made, some simple revenue analysis, and within a short while, I found out, of course, they were not all gaining market shares. Uh, there is a law of averages, so somebody's got to
Yeah.
go down. Okay, so that's really where it started. Um, and then I realized that most companies use market research. And I've realized that nothing happened as a result of this market research. So I just put myself to the test and say, okay, can I find a piece of market research that shows my company is growing? I could. Could I also find a piece of market research that showed that we were not growing? I could. Okay. So what companies do, and this is not the fault of the CEO, this is the fault down in the machine room. Uh, Companies simply pick the market research that makes them look good. And then they go to the CEO and say, see how well we're doing, you should pay us more. And then the CEO goes to the market and say, we're gaining market share based on, really flawed numbers. So once I started to do gymnastics on this, I realized, okay, this is fun. I want to do some of this. So I took an MBA, and that was also fun because that opens up your mind. I know a lot of people say, MBAs are ruining the world, blah blah. Not at all. It's learning, and you could use it for anything. So I actually got so interested that I started teaching for a couple of years. I was teaching strategy and corporate finance. Taught me a lot about what I needed later on, and then I started to fly solo. And what I'm doing different to other market research companies is that I'm not that interested in sizing, because sizing is so difficult, so easy to manipulate. No, and also, you go and tell a company, hey, you got 16% market share, and they go, rah, rah. Then you tell them you got 18. They're not doing anything different. You tell them that you got 56. They're not doing anything different. So why at all do market research? What you want to do instead is you want to tell them what's changing. So this is my concept of dynamic market research. And that really goes into, okay, there's something coming towards you, a wave. It's propagating and we can see it already. And that's fundamentally going to change your business. See, that's much more interesting for a company to deal with, because the first fundamental question of strategy is what is going on. Not what's the level of it, but what's really going on. So once
Really
I
going.
got that established, then I started to have some clients that were very interested in talking to me. A little bit to my surprise, the financial institutions were very interested in what I was doing. So a large proportion of my customers are Wall Street banks. I hope that makes sense.
Yeah. It gives a lot of uh, remote view from my side, and also to the audience what the semiconductor market research is, because this channel, the mainly audience are graduates, freshly graduates, and I think initial 3-4 years they have experience. We do have a lot of senior people also by the analytics of this channel.
Mhm.
However, people will understand what is semiconductor physics and etc from the tutorials that we publish. And now from your side, they will be able to understand what is the semiconductor market research and what does that mean, what does have the impact. You've given us a simplified picture to understand the thing. Thank you very much for your answer.
Mhm.
And now I will go to the next question. What exactly the semiconductor market research involved right present, and why it is critical to the VLSI ecosystem? Why this market research is very much important and critical?
Yeah, so maybe I can. I think that AI is quite, a hot topic at the moment. And maybe what we do is we know that AI starts somewhere in the belly of Microsoft. Somewhere they build a data center where there's a large, server. And this server apparently is a new kind of server called an AI server. So it doesn't use traditional CPUs, it uses GPUs instead, which is really a graphical processor. And it's what we use in our graphic cards, from the good old days. That's also where NVIDIA started from.
Yes.
So you know that there's a server in there somewhere, but that server is an incredibly complex system. It's got 40,000 plus different, components. And it's interestingly, it's made in China by a Taiwanese company on the orders of an American company. Okay, so it's quite already there. We're complex. We're not even starting to talk about semiconductors. Then we look at what goes into it. The new Blackwell computer that NVIDIA is introducing now has 7 main semiconductors in it. The most famous one is, of course, the GPU itself, that is consisting of 2 parts. These semiconductors are made by one company in Taiwan, TSMC, that you probably also heard of.
Yeah.
And TSMC gets their wafers from 3 companies in Japan. So now you can see already there's a huge chain of flow of components, and all of this is new. A year and a half ago, nobody's ever heard about an AI server, or a little over a year and a half ago. Right now, only a few people have seen a Blackwell. Next quarter
Yeah.
it'll start to become a hot ticket, and it's completely different architecture than H100. So suddenly, the entire supply chain has to change. When we start, one of the most critical areas is the semiconductor itself. So everybody knows that TSMC is probably the leading company here, and TSMC, whenever they make a new factory, a new fab, they got to dish up something like 35 to 40 billion dollars. As Warren Buffett says, a billion here and a billion there, and soon you're talking real money. It's a big investment, and you risk that investment hitting a market where there's no demand. Because one of the problems we have in the semiconductor industry, because these large capital investments, is that the market swings. So there's a market swing of 4 years, 2 good years, 2 bad years. So you risk having your factory entering the market at the worst possible time. So that is why people, go and talk to me and say, okay, when do you believe the next downturn comes? And to a very large degree, it can be predicted. You just look at the different areas of the supply chain, and then you see, okay, I
Hmm.
can see it coming now. And then you give them an idea. And right now, my best, can you say, prediction is that end of 25 we'll see the downturn. And what we're seeing right now is that you have the CHIPS Act money in the US has incentivized a lot of companies to build fabs in the US. And let me try and think when maybe they come online. Well, let me guess, end of 25. So
Okay.
that's when the next cycle comes, and you have companies that have invested really at the wrong time because they wanted to get access to the chip money. So this is why this market research is important, because companies need to understand when should I make these big bets, these big investments, so I can time it appropriately, or else they'll get in serious trouble spending all of this money. I hope this makes sense.
Yes, it's a great overview, and it's a widespread horizon you have shown us and the audience, that why it is very much important to have a market research, and with very simple and very recent and very relevant examples. Yes, I understand. So nothing technical, but curiosity just came up. So we are talking about the AI servers right now, and
Yeah.
earlier, sometime earlier, I came across the ASIC mining system for the blockchain, etc., etc. So all these things are, I think, side by side, growing or something like that. So these are very much trendy things that in the semiconductor market trends, they are creating waves, and the waves somewhat hitting people, to some people, not to some people, and way of getting different paths to reach people, and there could be latency in those paths. Hopefully your opinion can help people to take the path which will connect those things to the demand and the supply.
Mhm.
Yeah. So over to the next question, that is, how does market research influence the decision making in existing semiconductor companies?
Yeah, so there's a there's an inherent construction flaw in most semiconductor companies, and that is in order to manage a large company. Most of the semiconductor companies are really large. There are 50,000 plus people in many of them. And what you do in order to sort of control is that you divide it up into divisions. The
Hmm.
most common way is you divide it up into product divisions. And then what you see is suddenly what you do then is you have maybe your strategic review every year, where you let each of the division presents, and then you decide in senior management who should have the resources, because this is really what a divisional split means. So you have X amount of money to give, and all the divisions want all the money. So now you have a competition. And often that competition is harder than the external competition. So you see divisional vice presidents get much more excited about the other vice president than an external company. The best example of this is Intel. Intel probably powers a few computers that are viewing this right now. And Intel has a very, very large division called the Client Computing Group. And right now, with the exit of Pat Gelsinger, the new, can you say, interim CEO is Michelle, who used to be and still is the senior manager of the compute division. So you have there basically that division has won right now, and all of the others are struggling, including their data center business and others. So this is not healthy for the company, but it's very, very normal. And if you have traditional market research, each of the divisions will come in and say, see how good a job we're doing. Our market is growing, you should invest in us. We're growing, you should invest in us. But the reality is, it's not true. Senior management needs to get out of the divisional thinking. They need to look outside the company for neutral input, okay? And not just listen to somebody who's got skin in the game. If I talk to my manager and I know if I say I'm growing, it gets me more money, I'll say we're growing, okay? I'll find a way to make that happen. So some companies then call me and say, you know what, I got 16 vice president. They all say their market is growing and they're doing better than the others. And I say, that's not actually true. And I can tell you who's growing or not. But that's not really the question you should be asking. The question you should be asking is, what's going on in my markets? Where is something changing? And it doesn't always have to be positive change. People always talk about, oh, where's the next big opportunity coming that I should look for? What you should also look for is, there's a shark out there and it can smell you now. Okay. So watch out for the sharks. So one of the sharks that Intel didn't see was they were number one delivering CPUs to the data centers. They were having great fun and thought, we're a great company, we make a lot of money. And suddenly, ChatGPT and OpenAI and NVIDIA started to work on stuff that Intel were not working on, and that started a revolution. A big white shark grew very, very fast. And Intel has not to this day been able to resist that, meaning that they're now in deep, deep trouble. They have red numbers, while at the same time, NVIDIA has grown to $35 billion a quarter, of which most is profits. So it's an incredible big shark that they missed. So those two questions are really important: is what is going on in my market that can threaten my position? And
Yes.
what new juicy opportunities do I have? And they don't come from levels. No, they don't come from, oh, the data center market is, 67 billion. No, that doesn't make a difference. It comes from somebody's doing something. It's coming towards you as a wave, as a big shark, and you better prepare now. Okay. So that's why they need to come out and talk to me, because most often the change does not come from within the market. It almost always comes from without the market. Okay, and that's where most
Yes.
companies miss, because they're experts in their own market, and then they realize, okay, oh, there's not a market anymore. I can't sell my GPS system because it's now on an iPhone. Oh,
Yes.
isn't that another market? Where's the small digital cameras gone? Well, they weren't killed by another digital camera. They were killed by the iPhone. So you have this, can you say, threat almost always comes from outside the market. And that's why I don't just look at the semiconductor market. That's one of approximately 30 markets I look at, because
Great.
I know that out here, this is what's going to shape the semiconductor industry. So I hope that makes sense.
Yes. Yes. Perfectly makes the sense, because like when a tornado builds up maybe in the sea level, it's small, but when that gains power with water and all these things, when it hits the ground, it's devastating.
Mhm.
So what my understand and how I am rephrasing that, the market research helps to pinpoint those tornadoes which are right now growing somewhere in the sea, and which is far far away from the uh, uh, land. Okay, so people are in land will be aware of the growing tornadoes.
Yeah, exactly. And it's like, so you can boil down strategy to three questions. So often, somebody says we have a strategy, but most often they just mean a plan. A
Yeah,
plan,
yeah, yeah,
it's not a. You can have a
yeah.
strategic plan, but it's not like, hey, I have a plan. That's a strategy. No, that's not a strategy. Strategy is something else. It's a response to changes in the market, and it's constantly changing as the market is changing. If something is changing, you should change your strategy. So you have,
Yes,
for me, you have three basic questions. The first one is, what is going on? This is where everything
yes,
starts. What's growing, what's going down? Where do we see a change? Where's a wave coming? Once you have established that, you need to decide, what can we do about it? Because
yes,
Intel doesn't suddenly start making submarines or rockets. They have a sort of a they have an area where they are strong and areas where they're not so strong. So their response has to be tied to whatever they're good at. And that comes to the
yes,
third question: is the second was, what can we do, and the third one is, what will we do? And that's
Yes.
really the strategy. So if you boil it down to three questions, and that's where I help. I help with the first, and then people typically go, I am not going to tell Intel what to do. I can tell them what's going on, and then they can decide. My way of doing that is I present data, and then data from other areas, and then on that I build my theory. And sometimes people
Yes.
just want my data and not my theory. I'm okay with that. My theory is not always right, but my data is. And they can decide what they want to do with that. But I sort of get involved in the first question, and that can be in form of presentations or data or whatever. And that's, can you say, the most interesting piece for me is the first question, and then I'll let them go and do what they need to do.
Now, before going to my next question, the things that we know, if we get to know the history, we will be ready for the future. So this is applicable to semiconductor market also. So how the semiconductor market has changed over the last decade from a bird's eye view that you have, can you share?
So I was talking about the semiconductor cycles. So you have the semiconductor market overall is growing about 8 to 9% a year, but it's a very sharp up and a very sharp down. So right now we are in an up cycle. So we are, according to, can you say, the industry gold standard, which is called WSTS, the market is in a very sharp upturn and will peak within 2 or 3 quarters. And then, everything looks normal, but then you go and check, for instance, I check the headcount in the industry. So the headcount has not grown since 2022. So that's strange. There's an upturn, but there's no headcount growth. Then I go and look at some of what we call the hybrid semiconductor companies. They have some of their own manufacturing, and then they get some done by TSMC. And they are making sure that our gas boiler works, that there's a light in the house, and all of these boring semiconductors, not sexy like PCs or AI servers. And you go and look at their numbers, and they've been down for 8 quarters now, and they're guiding the next quarter down also. Okay, so I'm saying that's a strange kind of an upturn. No headcount growth. A lot of companies are not doing well. Then I go and look at TSMC. So TSMC has just made record revenue. And I look at what is their capacity at right now and what is their utilization rate. I look at that and then I see, well, TSMC is only at 76% capacity utilization. That means that they have a quarter spare. Still, they're doing revenue records. And what you find out is that most of this upturn is actually profit. So it's profit of NVIDIA and it's profit of TSMC. And there's no real upturn. The supply to the supply companies in the semiconductor chains don't see much. They look at it and say, well, we're an upturn, but our customers don't buy more. TSMC doesn't buy more. They buy about the same. Still, they have record revenue. So what you need is, can you say, you need some insights into what is really going on, or else you could just look at this upturn and say, invest, and then you find out that you're building a lot of capacity that nobody needs. So right now, for the first time, actually, the semiconductor industry is an upcycle that does not change the supply situation or the level of supply much. It changes the kind of supply quite a lot because it's dominated by AI now, and AI has a completely different supply chain. The normal DRAM you stuff into your PC does not work in an AI system. They need a special kind of DRAM, and that DRAM costs about 3x more than a standard DRAM per bit. And then you look at the memory companies, which is Samsung and SK Hynix and Micron, and you see they're all growing, but their capacity is not growing. They're shifting from standard DRAM to high bandwidth memory, and they're getting a higher profit. So again, here you got no capacity growth, but a lot of revenue growth. Okay. So this is not normal at all, and there's going to be a lot of companies that are going to get in trouble because of this, because they're investing right now maybe where they shouldn't, or maybe they're investing in the wrong areas. So this is just an example of what goes on. You also see in you have Chinese companies that are now starting to make semiconductors, and they're creating a bloodbath, in some of the foundry areas where you actually do the manufacturing of semiconductors. But TSMC doesn't care because they are in the high end and they're alone. So they let the bloodbath happen at the bottom of the market, and they sit on the top, taking all the profit. TSMC is about 70% of the market and 97% of the profit. They capture everything. So this is very unusual. And this requires, can you say, um, it's like walking barefoot in a dark room full of glass, shattered glass.
Yes.
You have to
Yes.
walk very, very carefully. And I'm trying to, not always successfully, but I'm trying to warn my clients that it's different this time. And to first of all make them, realize that they really need to be careful in this period, because there's going to be so much overcapacity in the end of 25 that we've never seen before, and potentially it'll kill companies. So they got a break right now, and take in oxygen and say, okay, what's really going on? So I hope that that is an example. So AI is certainly changing everything, no doubt about that.
Great, great, great. So one, like you have said, the AI thing that shaping the market, right? Is there any other thing that started, like I mentioned about the blockchain and the ASIC miners and all those things?
Eh,
Uh,
mhm. Yeah. So
that
block.
that common people can relate. That means not sophisticated, but common students can relate. That
Yeah.
things.
So let me give you a story. So back in the 90s, late 90s, I was uh, I was starting to invest, because rather than just look at my bank account being smaller, I decided, okay, I'm starting to invest, and I might as well invest in something I know something about, like semiconductors. So one of the things I did back then was, you had computers that actually worked, reasonably well, but they were not very good at graphics.
Hmm.
So a company decided, okay, we can do that because graphics is controlled completely different from data. It's a lot of simple instructions that needs to be done in parallel very fast. So I said, who's the best at that? And at that point in time, there was a small company in the US that were very good at that, and I actually had one of their cards for fun and games, and it worked really well. So I bought shares in Nvidia. Buying shares in Nvidia in '97 was um, interesting because it looked like a good time, and then it looked like a very bad time because we had something called the dot-com crash, and then it was a very good time again. Now, of course, I don't know. It's probably a few cents they cost me at that point in time. I don't know. It's a lot of money now. But what happened in the meantime is that of course Bitcoin came up, and blockchain, and now you needed to mine, which is a very much an operation that is very, very good for GPUs to tap into. And the problem is that, of course, this is the law of diminishing returns. For every Bitcoin, you have to work harder, and there's only a finite number of Bitcoins left. So this became a race, and then of course Bitcoins goes up and down. I think right now it's probably at the highest level. That means that it's very interesting to mine, but there are other periods of time where it's not so interesting to mine. And one of the problems with mining is it requires a lot of power. So
Yeah.
typically, what you do is you need to find a location. The best location for mining is probably near a very big dam. Okay, that works. Because you don't need to mine all the time. You can mine when the electricity is low and then stop when it's not so low. And really, mining drove a lot of Nvidia's business probably back in oh, 2019, 2020, around that period. There you could see that it was an important part of their business, but not anymore really. Today, it's a small fraction compared to the AI. AI is where you can make the money. Bitcoin is now more um, hard labor. Okay, where
Yeah.
it used to be the golden, it's now hard labor. The last coins are going to be expensive. Are they going to be worth doing? Probably, especially at today's rate. And then a lot will mine again and blah blah blah. But soon it's going to end anyway. So I think it just shows that it is a very good technology that they have that is very different from a traditional CPU. But AI is already it's already probably 100 times bigger than Bitcoin mining ever was. And this is can you say this is the new oil? AI,
Yeah.
you have companies investing outrageous amount of money, even though you don't know if there's a return on AI yet. So I think that's really how I would try and frame
Yeah.
blockchain and bitcoins and mining.
Yeah. So that was very great information from your side. We'll move over to the next question. That are there any emerging technologies or application that you believe will drive the next wave of growth in semiconductors?
Yes. So actually, AI is driving a very, very interesting development. And the development is that if you take NVIDIA have now made their third platform, Blackwell, and that platform uses the same semiconductor technology as the two others. So it is a 4 or 5 nanometer TSMC technology, and actually it's a lot less advanced than what I'm sitting here talking to you at. I'm at a Mac M3, which is a 3 nanometer processor, some of the most advanced technology in the world from a semiconductor perspective. But actually, NVIDIA have managed to wrestle maybe 100x more power out of their newest AI platform without actually using a better semiconductor technology. And that sounds like, okay, how the hell do they do that? And what they're doing is, first of all, there's a size limit to how big you can make a die, which is the silicon that is basically a semiconductor, and that is something to do with the tools. You use light, and it's called the reticle limit. And basically, most of the advanced semiconductors is at that limit. Also, the M3 and the processors in your iPhone and stuff like that. And what NVIDIA managed to do is to glue two of these together. So they now have a 2x size processor, um, which is put on a substrate that's incredibly advanced. This substrate is something that can only be done in Japan by companies that do film for fish packaging. It sounds crazy, but it's true. And then so they suddenly have a very, very large processor, and you need proximity is very important in order to get speed up. And a GPU can do nothing. It needs memory, and needs working memory. It needs a lot of it, and it needed close. So it cannot go out and in of the package. There's too much resistance. It slows things down. So what NVIDIA needed to do was they needed to glue the memories very close to the processor. So my pardon for being a little bit technical, um, but a processor generates a lot of heat.
Yes.
You have fans on your PCs, high-end PCs and stuff like that, because it gets very hot. Then you have a DRAM. A DRAM is very delicate. If it gets up to 75 degrees, it starts forgetting. If it's get to 85, it's gotten complete Alzheimer's. It's forgotten everything. Okay, and now you want to bring this very delicate component very close to an oven. That's not only stupid, that's very stupid. But this is what they have to do, and that's what they're doing right now. So they have 8 stacks of memory very close to Blackwell, and they're managing this very very difficult thing. So what you're going from is from a CPU or GPU to a processor board that includes memory, and that is going to happen in the PC as well. It's going to happen in cars, and it's going to happen everywhere else where you have a high compute need. So that means my prediction is that we have this AI, PC coming. Yeah, whatever. I think what's more interesting is that the PC will become a lot more powerful once you get can you say, this kind of architecture into the PC and everywhere else where you need this high compute. And that, of course, is just one area. There are other areas called chiplets where you know, you basically do many different kinds of chips, not just CPUs and memory, but all sorts of others, and package them into very, very small areas. So I think where there's a development in semiconductors being smaller and more effective, there's also now a very, very strong development inside how you put these things together and how you package them. So it's called advanced packaging. It's an area that is very much home in Taiwan and Japan, and Korea. That's where they're doing all of these things, and they are incredibly advanced. It's incredibly difficult, and it'll make a big change to everything, I think. So I hope that sort of gave you an idea of
Yeah.
going on.
Yeah, I understand, and it was a very broad and elaborate example. Yeah.
Mhm.
So moving over to the next question, that does the market research has its impact on the innovations that are happening in VLSI and semiconductors?
That's a little bit hard to say because um, so there's some research going on that is not really related to any markets. Okay, so it's not like we say, "Oh, I can see a hole in the market. We need to go and fill." You go and talk to some R&D people, and they go do it. No, that's not how it works. So we have people that are working on faster memory, and that's not for any particular area. That's for any area. And then you have what I was talking about, high bandwidth memory, which are stacks of memory with a very wide interface, so you can access it very fast. But you also have what we would call standard DRAM, which is DDR5 and DDR6 and DDR7. So that's a can you say development track that goes on independent of products, because we know that sooner or later, probably sooner, we'll need faster DRAM, and you see that in every area of the industry. So there's something called Wi-Fi 6. So when I hear something like that, I think there's probably also something called Wi-Fi 5 then. Okay.
Yeah.
So and so forth. So there's a continuous development of each of these technologies, and every once in a while we take a leap. We need something new. So that is one end of this is the curve that goes up. Then you have market product curve that goes down, and see if those two can connect. When those two connect, something magic happens. So what I do is I work on this curve here. I say to companies, well, okay, we can see that there's most companies know that, AI is hot. Yes, it is. But they don't know how hot. I know how hot because I have the data. So one thing is knowing that something is going on, but the velocity of it is quite important, because then
Yes.
you need to find out. So let me give you an example. Right now, Nvidia is ruling, but there's a couple of companies that have decided we also want to play. And one of these companies is Broadcom. They probably our internet connection right now is probably running on some Broadcom equipment, but they've decided that market has been depressed now for 8 quarters. We also want to do some GPUs for AI. And funnily enough, Google were very tired of Nvidia's pricing, so they have their own architecture. And Broadcom has a lot of knowledge about semiconductors. So right now, Broadcom are working for Google in turning out new AI processors, and they're quite successful with that. Not to the same profit levels as Nvidia, but nevertheless, and they're also only a fraction of Nvidia's market. But what they've seen is that they've seen this is in a massive market that's growing. It's going to grow from one architecture, that's very much focused on learning right now of the big language models. But sooner or later, these models need to work for us. This is what's called inference, meaning that a model that's now been trained and learned are ready to actually go do stuff for us. And inferencing is a lot more fragmented than learning. In learning, there's NVIDIA and nobody else. Inference is much more fragmented. So they're interested in understanding, hey, what is how fragmented is this market? Not just, is it fragmented? They know that, but how fragmented is it? So I can tell them that right now, 85% of all enterprises plan on using an existing model. So they will not spend a lot of money and time on LLM. They'll spend a lot of time and money on inference. And that means that Broadcom are saying, hey, great, because inference is fragmented. And we know now that we have a big market we can go after. And NVIDIA can't beat us in under every rock. There's places to hide. There's places to invest. So this is an example of, yes, we know AI is a thing. Yeah, we know HBM. Yeah, I know, but you don't know how much or how fast. I know that. So that's a difference. If you can see, the idea is that sort of quantifying the size of the change is quite important in changing and in having these new technologies intercept with something that can become a product that can generate revenue.
Yeah, I got it. And let me rephrase that. Means the two cars meeting, it's like there is a ballistic missile from one end, another ballistic missile from another end, and they had to be head on. So momentum has to be calculated so that they can make an impact by head on.
Yeah, because you can't develop technology that's of no use. If there's no need for Wi-Fi 6, then we'll probably not see Wi-Fi 7. Okay, but as long as there's sort of like a new idea, it'll keep growing, but it has to eventually turn into a product. Wi-Fi 6 in itself is worth nothing.
Yeah. So that was a great answer from your side, and let me move on to the next question. That is that. This is a common trend that in maybe past couple of years or over the last decade we have seen that how do the bigger companies sustain while the smaller companies get acquired by them? So there is a trend.
Yeah.
So how this happen?
Yeah. Okay. So so that trend has stopped in semiconductors. I think I have a demarcation line that's probably around 2014. Before then, semiconductor companies were being acquired and they grew and just became bigger and bigger and bigger. But after 2014, that stopped. And one of the reasons that it stopped is that China had made a plan many moons ago that they wanted to become self-sustainable in semiconductors, because they looked at all their factories. Then they looked at, there's a lot of iron, there's a lot of plastic, and then there's some of these little thingies, we don't know what they are. And what they realized is that all the value was in semiconductors. All the other, nuts and bolts didn't really count for much. It was the semiconductors that made the difference. And that is firmly owned by the US still today. The IP is American. So they decided to invest a lot and had invested an incredible amount of money. And slowly, they started to become a superpower in semiconductors. That also meant that other areas of the world were starting to realize this. And when you do a merger in the semiconductor industry, you're very dependent on getting an approval in all areas of the world, because the supply chain is so scattered. And it became very difficult after 2014 when it became very visible. So you could go and do a merger. There were several big mergers attempted that went nowhere because you couldn't get the approval. So basically, semiconductor companies have stopped doing M&A. And that means that there will probably come new companies again. We still see technology mergers, but not, can you say, revenue seeking mergers. So, I still think Intel probably buys 35 companies a quarter, and same Nvidia probably does the same. But these are, small nuggets that you pick up. So you don't see this anymore, and I don't think you will. US is never going to allow anything Chinese buying anything American, and the same with the Chinese. They're not going to allow any Chinese companies to be acquired by the Americans. So that has stopped. In other
Yeah.
areas of the world, it probably does still happen, but it will never happen in the semiconductor. No, I say never, but for the foreseeable future, this would not happen in
Yes.
the
Yes.
semiconductor industry anymore. So you have to acquire the technology, and then you have to go and develop it. And I think for NVIDIA, you could see about 3 years before their first AI server came out, their headcount started to increase dramatically. So you could see that they were preparing something. I have to say that I didn't catch it. I only caught it afterwards. But all the signs were there that something was going on. So now companies need to make, can you say, the bet in their own garden. They need to sow in their own garden rather than just go and steal the neighbors. And I think that's probably an okay thing. That this is what happens right now. So there's still concentration, so there's still more revenue on fewer hands, and this is because of TSMC and NVIDIA, but it's not happening through M&A, it's happening through development, and this big change in the market towards AI.
Right. So that was a great answer, and that spreaded light to multiple areas that actually people get know about, because most of the time the news are here and there, and they are not from the core semiconductor personnels or experts. So the news get molded by the words, and words are not by the maybe engineers or maybe professionals from the semiconductor domain. So that's why they become a bit confusing to get there. Now you have cleared the vision, I think, to mine and to the audience, and that will be very much sustaining, as because this video will going to retain in the channel, and people can later, who are doing the playback and they are watching right afterwards, they also get that view.
Yeah, I
Moving
think
over to the next.
now
Yeah.
just a comment to that. I think the really dangerous things is that if you go back 5 years, you never heard a politician talk about semiconductors. You go today and they talk about semiconductors all the time. And I know, especially in India, they're talking about semiconductors all the time.
Yeah.
Okay, that's every second word almost. Because
Yeah.
also India wants to become, an important player in semiconductors. That's understood. And once politicians gets their hands on it, it becomes oversimplified. I'm afraid, and that's where they need a few of us that have an idea of what goes on nearby.
I will not take the name of the country. The country got a little huge budget over their semiconductors. They don't have their government, I think, policies yet. People are fighting to get the policies. I'll not take the name, because here this is just a information. It's not a political debate. So,
Yeah, yeah, exactly.
adding to your,
I don't worry about politics. I
yeah,
get involved in politics because that's now a driver of the semiconductor industry.
yeah,
But I have no preferences for who wins or loses. What I'm doing is I'm trying to honestly and neutrally report what I see, and
yeah,
not carry water for one government or the other. And
yeah.
I'm in Denmark. That's probably the worst place in the world for a semiconductor guy to be. There's absolutely no semiconductors here.
So even I am viewing this from Calcutta, and Calcutta do not have the semiconductors at all. There are IT companies here, but in Calcutta, or rather, the present name is Kolkata. Uh,
Yeah,
so yeah, so it do not have any semiconductor companies from where I am viewing this podcast. So I can relate to your thoughts.
yeah.
I can relate to
Neutral,
your thoughts.
neutral is the word.
Mutual is the word, right? Right. And all now moving over to the next question, that as a market researcher, right, you are seeing a lot of trends in simple words, can you say what's coming ahead? So we have seen the boom of the smartphone, we have seen the maybe the blockchain, we have seen the AI, right? They are coming. So anything that is coming according to you going to be there, maybe hot and happening? It may be technologically. I'm not going in the direction of the revenue because that will be the interest of the CXOs. Okay.
Yeah, I think so. I think the PC was the first product that really changed the world based on semiconductors, if you could say that, and it's still doing that. Although now it's a quite mature product, and but it still has some life to go. Right here in front of me, I got an iPhone and an iPad and a Mac. What and some screens. Okay, so what else do I need? But that'll develop for sure. But what is happening now is that the we are seeing a technological leap. So when I was a young lad, semiconductors were everything, and we didn't need to program much. We had very small micros with very small memory, and we only needed this strange guy sitting in the corner doing some code, and then there were 10 of us doing hardware. Now, of course, it's reversed. There's a lot of software guys because there's a lot of memory in the processors. But what you also see is that the LLMs are incredibly good at coding. You can have a conversation with them, and sometimes you say, "God damn, how stupid can you be?" Sometimes the LLM is very smart. Other times, I just shake my head and say, "You can't do that." But in
Yeah.
coding, there's no question. The coding is incredibly effective, and I don't know any software people right now that doesn't get probably 70% of their code made by AI. And eventually that means that there's probably going to be less need for software people. That's
Yes.
not going to be a good thing for India unless India moves.
Yeah.
But AI has a completely different, it gives capabilities to people and it will kill jobs. So let me give you an example. I follow several Chinese companies, and I've been dependent on somebody that can help me. I got a few Chinese and Taiwanese friends that give me a hand because my Chinese is horrible. But now I don't need them anymore because my AI speaks Chinese. It can read through reports to government legal documents and everything, and it can present it in, what do I know, Swedish if I want to. So suddenly I have a lot more capabilities without having to hire somebody. And that's what's going to happen to with AI. AI is going to give us specialist capabilities as ordinary people. Okay, so people do not need to understand how to program a system. They need to be able to describe what they want. And then this will build an app. Is this what you want? I want a different color there. I want this, and this changes it. So we're in front of a massive, massive, massive disruption of everything, and technology will start to become invisible. Okay, so right now we have an iPhone, but probably the next level won't be visible to us. It'll just be something we talk to and be able to understand. What do you want to do? So for instance, you still have probably a washing machine in your home.
Yeah.
You probably still have dials and buttons and all of that stuff on. And
Yeah.
i'm
Yeah.
and I'm saying, why? You got your iPhone nearby. Get rid of all of these buttons and just let the iPhone do it. But very soon, you're not going to see buttons on their displays. You're going to talk to it. And it's not going to
Yes.
be
Yes.
it's not going to be that expensive either. You'll talk to your coffee machine, you'll talk to your door, you'll talk to your dog's collar, and so I think this is what's going to dramatically change everything. And I think industries will die. So already now you have the big consultancy companies that are, Ernst and Young and all of these guys, McKinsey. They're already probably having 70% of their presentations are now made by AI. Okay, and then they say, "Hey, great, we're saving a lot of cost," and I'm saying, "No, you're not. because I can do that myself. I don't need to hire McKinsey to do that. So first, what you're seeing is that all of these companies have a lot of stupid processes that leads to nothing. And now they're giving it to AI, but that doesn't make them better. It's just lowering their cost. So for instance, if you look at LinkedIn today, I think 3 out of 4 posts now are probably AI. I don't use them because I think that there's still some value in me actually writing it. I might be wrong, and then I'll just not be here. That's fine. But it's because companies have found out, oh, we need to do 60 pieces of content this week. Oh, let's go do it. So AI can do it more effective. What they're not thinking about is, what's the engagement rate? Do you get any customers in? No, they don't.
Yeah, yeah,
Most of them
yeah,
just
yeah,
have
yeah,
one like, and my stuff, if it's a good one, it gets 2,000. If it's an average one, it gets 150 likes, So I believe that you need to adapt to this new environment where if it's brain dead, then it looks like AI and nobody's going to like it. So you need to put some true brain power into it. And if
yes, yes,
in everything you do, and if you're not using your brain in your job, I can guarantee you there's going to be a friendly AI that can do that, and your customers will do it. It's not your company. That's what they're thinking right now. Oh, let's get these working for us. Nah, come on. Your customers are gone. They can do that themselves. So that
yeah,
is fundamentally changing everything. Okay.
yeah,
So I know people were looking for, is it the new glasses, Google glasses or something? No. This is going to look very different. And it's I must say I'm very much first scared by it and also looking forward to it. I think it's the
yeah,
Chinese
yeah.
that say, their worst curse is may you live in interesting times, and I think we are.
Yeah, if there is a let me give a fictional scenario. If there is a globetrotter person, right, he goes here and there in the world, and he have the Google Glass, which is maybe it's also a fiction, has the AI enabled. Tra- it translates the other language, whatever we see. Say he goes to a country where the language he even don't know what language that is,
Exactly,
but the AI can recognize and it can translate to him in the glass. That
exactly.
will be helpful.
It'll be very helpful, but we need to distinguish between information and capabilities. So let me give you an example. So I have traveled a lot over the world and done a lot of business. Done a lot of business in Russia and in China, and I can have a translator with me. I can have everything translated, but that's not the same as doing business. The way of doing business in China is very different from the way of doing business in Europe, and an AI can't fix that. They don't understand all of those cultural differences, and what do you need to do in order to create that relationship that makes business flow. And that's capability, human capability. So what we need to make sure of, each of us, is that we're building these capabilities that are everything AI can't do. And
Yes,
every year AI will be able to do more, which means that we will have to be even higher level capabilities in order to survive. So for me, it's an advantage. I'm a one-man operation. Well, got a few helping hands here and there, but in reality, every month I gain more capability because of
yeah,
AI and its ability to help me find the right areas to research. I don't let AI do the research because it's not accurate enough, but it can
yeah.
point in the right direction. So I hope this
Yeah,
makes sense.
I can yeah, I can also rephrase that for me what I got it. Because when we are humans, we emote, we feel many things, inflation, blood, body languages, all those things,
Exactly.
that cannot be replaced by AI, definitely.
No,
But
not
what they can do, they can help us in uh, breaking down the complex stuff that we will take a longer time to digest and process and all that, so that can they can do very easily.
yeah, and it still lacks some of the, can you say, empathy and things like that. So you go, for instance, to Copenhagen, and everybody can sort of, you can have AI tell a story about Copenhagen. Nobody gets excited by that because it's just information. What you need a good storyteller. Somebody
Yes,
can do the gestures, that can find out what is this audience interested in. Is it a group? Is it a bus full of people from India? Well, they have, can you say, a different cultural background that makes them interested in certain things that maybe a bus full of Chinese wouldn't be. So, you need
Yes.
to adapt to that and then say, okay, what stories can I tell them that's interesting in an Indian context? Uh, and that could be stories maybe about we have certain companies that started because of India, okay, and trade and
Yeah, yeah,
exploitation, whatever call it. But
yeah,
so there may be stories there, but this an AI is not very good at the moment. It's better at information.
it cannot come out of the box and come into the world where the sunlight is there, the moonlight is there, and everything is living and moving.
Exactly. But of course it'll get better, and there's no reason that we shouldn't prepare for that now. So
Yeah,
if there are young people out there, make sure that uh, whatever field of study you choose, you'll choose wrong. So don't worry about that. That's not the same as not saying it's good to go to school, because the most important thing you can learn in school is learning to learn, and learning to
learning to learn.
yeah, and learn to be critical, and learn to say, okay, this doesn't make sense. Learn to be logical, okay. Learn to
Yes.
be brave, because when I did my engineering degree, there was no computers. There was one computer in Denmark, and I could get a little bit of time on it if I wanted to do some punch cards. So, and now I'm working with computers. It's like, okay, so I had to teach myself that over several, years. So you have to constantly make sure that you upgrade yourself and don't just sit back and relax, because then there's a big white shark underneath you, and it's called AI.
Yeah, yeah, yeah. So moving over to the next question, that is uh, it's about you, right? So people have came across this interview here in this podcast. So if they want to connect to you, get information about your newsletter, how they can do that, means connectivity wise?
Yeah, so the best thing I think is to you can find me on LinkedIn. That's where I do most of my outreach. So even if you're trying to avoid me on LinkedIn, it's probably difficult to avoid me, because I there's a lot of can you say there's a lot of um, I would say hunger for what I'm doing. People are very interested in my analysis because they again include a lot of data. So I think LinkedIn is a good outreach point. And I typically connect with everybody. If somebody thinks I'm interested enough to connect with, I probably will connect back. Maybe not the same day. Where I do my analysis, sort of external analysis, is on Substack. So there's a Substack under my name, or there's a Substack under Siliconomy, as in silly and economy. So there you can find me. There are sort of two levels. I have a paid level, which gets access to the entire advanced analysis and the conclusions. But I normally give quite a good bit for free. So I think I still have a lot of free subscribers that believe, the free bit is good enough. And finally, I'm quite good friends with the Google search. So I rank pretty high there. So you can just go and search for me there. I
Yeah,
have a homepage also, but that's more for, can you say, corporate clients, where they can get direct access to some data and so on. But I think the best, if you found this interesting, then go to Substack and connect. I typically don't get super technical, but of course I can't. I have to have a certain level of technical skills in order to write. But normally my introductions try and set the stage for what I'm talking about from a, can you say, relatively open a level. So there should be something for everybody.
yeah, great to have you in this show. And the final question is that we have a lot of freshers. You are a person who have experienced long years in different sectors. You have met different um, cultural people across the world. For freshers who are just starting their career, is there any message for them so that they can get a right way or right path in their life?
Yeah, I think so. One of the things that is dear to me is what I call the truth. And when I talk about the truth, everybody rolls their eyes because they say there are many truths. And I say, yes, I agree, there are many truths. Two things can be true at the same time. But what the world is in critical lack of is critical thinking. People read something on Facebook and then they run around with, their hair on fire. Have an engaged brain. Okay, there's several ways of actually finding out if things are true or they're false. Okay, and I think that's the first starting point for everything sensible development in business is don't run with all of this stuff. Okay, check it. Then just say to yourself, is that true? So you see ads today, conspiracy ad, like the big companies have decided that you should not have an effective heater. So this Swedish engineer have in his backyard made a very efficient heater. It's so small, it uses no power, and only costs $1,000. And you go like, I need to buy it because it's expensive. All of that is, just fake. And you know it. You just sit down for 10 seconds and say, why would a big company keep that from you? If I had that, I'd sell it. You can have it. You can have more. Hey, come on. I'll invent something new. So we need critical brains. And I was not brought up with the internet. I was not brought up with Facebook or anything else. So I have a natural resistance. I'm used to using my eyes and my ears and my mouth, as you can hear. So I have a different angle to all of this. But my daughters, they get caught by this a lot easier. So I have constantly worked with them to say, okay, does this sound right? And they go, no, it doesn't. Okay, then it's probably not right, but we can go and check. There are many good places to check. So become critical so that you never just buy it. And to be honest, when you get into a corporation, there's a lot of, I'll use a technical term here, bullshit. And a lot of it comes from your boss. Okay. So one of the things I always done is I always check my boss. And what I realize is that the level is outrageous because he's just running with things from colleagues and everything and trying to manage everything. Knowing that it's wrong is not the same as saying it. You want to keep your
Yes.
job, maybe, okay? But you need to know, okay? If they're pulling the wool down over your eyes, you need to know how much. So be critical, be cynical, and then do what you have to do, okay? But it
Yes.
starts with a baseline. If you cheat yourself, you'll be cheated by everybody else. So make sure you don't cheat yourself, and then you can see everybody else trying to cheat you. So I think that's the most important message I have. That has helped me more than anything in my life is the fact that I go, nah, I don't believe that. Let me go and check. Okay. And that's also the difference between an analyst and an expert. If you go on television and you are asking somebody, an expert, oh, so were you surprised about the war in Ukraine? No, I was not surprised. We have seen that coming. Oh, okay. Were you surprised by the raise of Bitcoin? No, we were not surprised. We see that coming. Then it's an expert. An expert doesn't need to check. They know. Okay. An analyst does something different. Said, did you see the war in Ukraine coming? No, I didn't. There were signs. We had seen some data that pointed in that direction, but we didn't see it. It was only afterwards that we could connect the dots. And then somebody, what do you think about Bitcoin? Where it'll be next month? Say, I don't know, but I can give you some of the data that points, to what has happened in similar situations and stuff like that. So what you want to be is, in my world, you want to be the analyst, because the analyst is a hell of a lot smarter, because the analyst always challenge their own assumptions. So when I start an analysis, I have an idea. I want to show that NVIDIA is growing a lot. For instance, an example, if we still have the time. So in NVIDIA's last result, everybody's just saying, oh, okay, nothing happened. But it's not actually true. The product that grows most inside NVIDIA is their downscaled version for China, which is completely surprising. That was the last thing I would expect. So when I saw that, the first thing was, that can't be right. I need to go and check, because in my mind, it was Hopper that grew the most, H100, to Microsoft and stuff like that. So I had to go and check, and I double check and triple check. Yeah, it's absolutely true. So what is happening in China is that their GPUs, homemade GPUs, are not very good, and actually Nvidia can sell their downscaled versions. It's very successful. So there's a lot of information in that. But an expert would just say, no, it's Hopper. It's H100 that grows the most. Don't you have to go and check? No, I know. So don't be an expert, be an analyst. And I hope
Yes.
this is a message I can give you. And the first you shouldn't be fooled by is yourself. Okay.
Yes.
And if I said something yesterday, I said Nvidia is going to do A, and then they start to do B. My brain says, no, they're still doing A. Else I'm wrong. Your ego is wrong. So put your ego to rest, and then challenge your own assumptions and challenge what you said before and say, is it still true? Or is something changing? Because you can easily fool yourself. So I think that's my message to everybody. Make absolutely sure, that you should not trust your teachers. You should listen to them, and then you should
Yes.
evaluate, and then you should say, okay, is this reasonable? Can I check it? Do I want to go with it? And later on with your bosses, yes, you probably need to do what the boss says, or you're a rebel. And I can tell you some famous rebels. Elon Musk is one. I can guarantee you Jensen Huang is a rebel. They didn't go to there just by being conventional. And there will be a lot less corporate jobs, I think, as in the traditional pyramid sense. There'll be a lot
Yes.
more jobs where you need to be a complete business inside your head, okay? Even inside another business, but you cannot just sit and do what your boss tells you. Tap on your PC, get a million zlotys or whatever, and then go home. I don't think that's where you want to go. You want to be a lot smarter than that. So maybe
Yes.
too many words, but I hope that it
Yeah.
makes.
Yeah. Yeah. The words actually help to expand the thoughts and your views about the freshers who will be going to the next. I think they will create some impact in upcoming maybe 50 or 60 years down the line. So they hear from you, and that is the message. And this will be recorded here in the podcast, and they will get those message. Even they, I say that everyone is not able to understand every word at the same time. Someone will absorb that today, someone absorb that tomorrow, and someone will absorb that maybe day after tomorrow. So it happens. People have different time latency in their understanding, and the critical thinking is the very 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 important thing, because in this social media era, right, everything coming as cooked food around
Yes,
us, and we see and we believe. No, that is not true, because if say I saw a picture, there was a cat was like, or sorry, a one owl was there, and it was like a one proper human height, around 5-6 feet, and that cannot be true. So
exactly.
even there is something AI generated picture, it looks so surreal, but it's not real. So the critical thinking
But
is
also,
helpful.
yeah, and also, does it matter at all? You see
Yeah.
something, and does it matter?
Yeah.
A lot of the time, 99% of stuff on Facebook doesn't matter.
Yeah, it's
Mhm.
I considered that of like old word, when the computer and PC started, garbage in and garbage out.
Yeah,
So a
yeah,
lot of garbage is coming, and it is coming and going out of our mind, so we have to
yeah.
flush
And
our
also,
minds and keep it clear.
with AI, you don't need anything in. You can just get garbage out. so,
Yes.
so this is.
Yes.
I think this is just a sort of fundamental, and also, for the young people on the call here, you are going to face a lot more change that I've seen. And I started without a computer, and now I'm doing AI. You're going to
Yes.
see a lot more change that I've seen. Just
Yeah.
this is going to happen for you in just the next 2 years. So be ready for change, and be ready um, to keep your meat computer clean. Okay,
Yes. Yes.
we need that to survive. Okay.
Yeah, so audience, we are talking almost 1 hour 15 minutes, and we Thanks, Klaus, for coming here, and it is very much honored to have you here. People who do not know about the semiconductor research and analysis about those things, because here this channel is mostly tech simplified, so we make
Mhm.
technology simplified here. And in addition to that, when that actually the which runs the business worldwide, actually those business which keep producing the technologies, that there is a matrix that keeps it binded. I think that is the semiconductor research and analysis that you are having the skill set.
Mhm.
So it was a very very honored to have you here today. Thank you
Thank
very
you.
much for coming to the podcast. And with I think this is the last podcast in 2024, and we are wrapping around a 1 year here today. We in this year we have seen lot of changes in the semiconductor domain, and many things worldwide. There was a lot of thing happen. So thank you very much, and a belated Merry Christmas, and in advance Happy New Year to you,
Thank
or
you
to
very
you
much.
and the audience.
Thank you very much for listening to me.
Yeah, thank you to you, and to you and to your family also.
Thank you.
Okay, so
Bye
bye.
bye.
Bye.